All right, we're with example 2 from Advanced Algebra 9-2 on exponential decay, where we have carbon 14, sometimes written as, carbon 14. This has a half-life of 5,730 years, which means that it takes 5,730 years for the amount of carbon 14 to be cut in half. And that's what this says. This means that any 5,730-year period, half of the carbon 14 decays and becomes nitrogen 14, and half remains. I have no idea what this sentence says. It's chemistry stuff, but I do understand that after 5,730 years, half of this carbon 14 is gone, and I guess it becomes nitrogen 14. So we're going to suppose that an object contains 100 grams of carbon 14. And we're going to let A sub n be the number of grams of carbon 14 remaining after n half-life periods. So A sub n is the amount of carbon 14 after so much time. So how many grams of carbon 14 remain after 4 half-life periods? So that means it's going to get cut in half 4 times. So we're going to take the initial value of 100, because that's what we started with, and we're going to multiply that by a half 4 times. So we're going to take 1/2 to the 4th power and multiply that by 100. So we'll take 100 times a half again, times a half again, times a half again. That simplifies to 100 times 0.0625. This right here is 0.5 to the 4th power. And then multiply 100 by 0.0625, and you get approximately 6.25 grams after 4 half-life periods. So let's keep in mind that's about, 30,000 years. We could also see this in a table. If I wanted to make a table, I could see this too if I didn't want to go right to kind of the method that I used here, where we have n is the amount of half-life periods. So initially we have no half-life periods, and there are 100 grams. After 1 half-life period, there would be 50. After 2, there's 25, 3, there are 12.5, and 4, there are 6.25. So we can kind of see it getting cut in half as we go. And after 4, there are 6.25, which matches exactly what we used if we decided to go the function route there. We didn't want to make it. How many years is 4 half-life periods? Just mentioned that. Now they're asking us, how many years is 4 half-life periods? Well, it's going to be 4 times 5,730, which is actually about 22,920, not almost 30,000 years. It's 22,920 years. So that's how many years it's going to take this carbon 14 of 100 grams to go down to 6.25 grams. 22,920 years. Let's write a recursive formula for this. A recursive formula is a formula in which we have one value and we need that value to write the next value. So we need to have the initial value. We know the initial value because we're told the initial value is 100. So A sub 0 is 100. The initial value is 100. And then to find the next value, to find A sub n, we need A sub n minus 1, or the value prior to it, or right before it. And we're just going to multiply by half. And this has to be true such that n is any number that's bigger than or equal to 1. That's the biggest number we can plug in here because we're not going backwards in time here. So this is what the recursive formula for this 100 grams of carbon 14 after n half-life periods. A couple more questions. We can write an explicit formula for this. So we have the recursive formula here, and that's, you say A sub 0, my mistake, that should be A sub 0 is 100. And then here's our A sub n equals A sub n minus 1 times 0.5 for integers that are greater than or equal to 1. And from this, we can write the explicit formula because we have the initial value, 100. We have the growth factor of 0.5. So we can just take this and say, well, A sub n is going to be 100, the initial amount, times 0.5 to the n power for integers that are bigger than or equal to 0. Because we can plug in 0 here, because that will tell us how much carbon 14 we started with. And that's in the context of how many grams of carbon 14 we have. Then we're going to write a function for the amount of carbon 14 remaining after any real number of half-life periods. So this is a little different than what we have here because we can then include, when it says real number, we can include negative numbers as well. So this is just going to be our basic exponential function. F of x equals 100 times 0.5 to the x power, where x can just be any real number. We could plug in negative numbers if we wanted to, or in the context of prior equation or formula, we're kind of just going forward in time. We're not necessarily going backwards in time. So this is our function for any real number, which is exactly the same as this formula here. This is in the context of x can be any real number.